Once again, welcome to our Cooled Care Maths class, and today we are going to learn about the second part of mensuration, and in this part, we will focus on volume and total surface area. And if you have any question or any comment, just feel free to type it in the comment section. So, let us start by defining the volume and total surface area. Volume is the measure of the three-dimensional space occupied by a solid object or the capacity of a container. And total surface area of a three-dimensional object is the sum of the areas of all its exposed faces, bases, and curved surfaces. So, we will start by calculating the volume of a triangular-based pyramid. But before that, let us draw the triangular-based pyramid and explain the important dimensions which are used to calculate the volume. So, this is our triangular-based pyramid, and this triangle at the bottom is called the base triangle. If we draw a line from one of the vertices of the base triangle, which is perpendicular to one of the sides, this line is called the height of the base triangle, with a small letter h. Then this side, which is perpendicular to the height, is called the base of the base triangle, with a small letter b. So, these two values can be used to calculate the area of the base triangle. So, if we add another perpendicular line from the apex, which is the top of the pyramid, to the base triangle, this line is called the height of the pyramid, with a capital letter H. Now, with these three, we can calculate the volume of our pyramid. So, the volume of a triangular-based pyramid is 1/3 base area times height. Hence, it is 1/3 in brackets half base times height of the base triangle, small letter h, times the height of the pyramid, capital letter H. But before we move to our example, I want to mention some other parts of the triangular-based pyramid. If we add another height on the triangle on the side, this is called the slant height, and also the lines which come from the apex to the base triangle are slant lengths. But take note that we don't use the slant height or slant length, we just use the perpendicular height, which is also called the altitude, when we calculate the volume. Now let us do our example. We are given this triangular-based pyramid with many values. So let us start by identifying the values that we must use. So this is the height of the base triangle with small letter h, and this is the base of the base triangle with a small letter b, and lastly this is the height of the pyramid with capital letter H. So, we can now use our formula for the volume of a triangular-based pyramid. If we substitute the values, we get 1/3 in brackets, half times 8 times 6 times 10. If we do this calculation, we will get 80 cubic centimeters. Now let us move to the total surface area of a triangular-based pyramid. This pyramid has 4 triangles, so you calculate the areas of each individual triangle using the base, and its corresponding height, the slant height, not slant length, and then you add all the 4 areas. So, to make things clearer, let us break down this pyramid into its individual triangles. We have this base triangle with base b and height h. Hence its area is half bh. Then we have this second triangle on the side with base a and height h1. Hence its area is half ah1. We also have this third triangle on the side with base b and height h2. Hence its area is half bh2. Then lastly we have this fourth triangle on the side with base c and height h3. Hence its area is half h3. So for the total surface area, we can now add all the 4 areas. Therefore, the total surface area is equal to half b, h plus half h1 plus half b, h2 plus half c, h3. So, I realize that in many question papers, the base triangle of the pyramid will be an equilateral triangle, which means all the sides are equal. Suppose the base triangle is an equilateral triangle. It means that all the triangles on the sides have the same areas. We just have to calculate the area of the base triangle and then one of the side triangles, and then we multiply by 3. Let me demonstrate this with a diagram. If we have this base triangle with base b and height h, then the area will be half b h. Then we have another triangle on the side with same base b, since the sides of the base triangle are equal, but it has its own different height h1. Hence the area of that triangle is half b h1. And we know that the other two triangles also have the same area. Hence the total surface area will be equal to half b h plus 3 times half b h1. Now let us move on to the volume of a rectangular-based pyramid. So this is our rectangular-based pyramid, and it has this base, which is a rectangle, with a length and a width. It also has this perpendicular height h. Therefore, we can calculate the volume using the formula 1/3 in brackets, base area times height. Hence the area of a rectangular-based pyramid is 1/3 in brackets, length times width times height. Take note that we also have the slight height and the slant length, but we don't use the slant height or slant length when calculating the volume. We use the perpendicular height, which is also called the altitude. So, let us do this example together. We are given this rectangular-based pyramid, and we have to calculate the volume. So here we simply need the length, width, and perpendicular height, which are 10 centimeters, 5 centimeters, and 8 centimeters respectively. Take note that we do not use 12 centimeters since it is slant length. So, the volume is equal to 1/3 in brackets, length times width times height. If we substitute with the values, we get 1/3 in brackets, 10 times 5 times 8, which will give us 133.3 cubic centimeters. Now, let us move to the total surface area of the rectangular-based pyramid. We can see that the pyramid has one rectangle and 4 triangles, so you calculate the area of the rectangle using length and width, and then calculate the areas of each individual triangle using the base and its corresponding height, the slant height, and add all the 5 areas. But take note that the triangles in opposite sides have the same area, so to simplify, you just calculate the area of the smaller triangle and the area of the bigger triangle. Then you multiply each area by 2 to get the total area of the 4 triangles. Let me break this pyramid into shapes so that it becomes easier to understand. We have this base rectangle with length and width, hence its area is L times W. Then we have 2 similar smaller triangles with the width on the base and with slant height as the height h1. Hence the area of the smaller triangle is half WH1. We also have 2 similar bigger triangles with a length on the base and with slant height as the height h2. Hence the area of the bigger triangle is half LH2. So now we can see that the total surface area is equal to L times W plus 2 times half WH1 plus 2 times half LH2, which can be simplified to L times W plus WH1 plus LH2. I have seen in many past exam questions that in most cases, they ask a square-based pyramid. But a square-based pyramid is a special type of a rectangular-based pyramid. So, we use the similar calculations, but they can be simplified even more. For the volume, the calculation is actually the same, and for the total surface area, it's also same formula and procedure, but it can be simplified, since all the triangles will be equal in area. So you just calculate area of one triangle and multiply by 4, and then add the area of the square base. Let me also break it apart to make it easier to conceptualize. So, we have this square base. Since all the sides of the square are equal, we can just call them bases b. Hence the area of the square is b times b. Then we have 4 similar triangles with the same bases b and same heights h, which are the slant heights of the pyramid. Hence the area of one triangle will be half BH. So the total surface area will be equal to B times B plus 4 times half BH, which can be simplified to B squared plus 2BH. Now, let us move to the volume of a triangular prism. So, we start by looking at the triangle, where we have base B and perpendicular height h. So, we can calculate the area by half BH. But since we need the volume, we will multiply by length L, which is the third dimension. Hence the volume is half BHL. Also, take note that we also have the slant length, but we don't use it for the volume. Let us do this quick example together. We have this triangular prism, and we need to calculate the volume. So, we simply use our formula half BHL, which is equal to half of 6 times 8 times 10, which is equal to 240 cubic centimeters. Now for the total surface area, let us break this apart. We have the rectangle on the base with length L and base B. Hence the area is L times B. Then we have the two rectangles on the sides of the triangular prism with the length capital L and slant length small l. Hence the area is big L times small l. Then lastly, we have the two triangles with the base and height h. Hence the area is half BH. So, the total surface area of the triangular prism is equal to L times B plus 2 big L times small l plus 2 half BH. And it can be simplified to L times B plus 2 big L times small l plus BH. Now, let us move to the volume of a rectangular prism. This is simple and straightforward. We have length, width, and height, which are perpendicular to each other. Hence our volume is simply L times W times H. For example, we are given this rectangular prism, and the volume is equal to L times W times H, which is equal to 10 times 5 times 6, which is equal to 300 cubic centimeters. Now let us break this rectangular prism apart so that we can see its surfaces. We have the top and bottom rectangles with length L and width W, hence the area is L times W. Then we have rectangles on the longer sides with length L and height H, hence the area is L times H. Lastly, we have the rectangles on the shorter sides with width W and height H, hence the area is W times H. Therefore, if we add these areas, we get our total surface area, which is 2 L times W plus 2 L times H plus 2 W times H. Now, let us move to the volume of a cylinder. A cylinder has radius r and a height h. So, the volume is base area times height. But since the base is a circle, therefore the volume of a cylinder is pi r squared h. For example, given this cylinder, with radius 5 centimeters and height 10 centimeters, the volume is equal to pi r squared h, which is equal to pi times 5 squared times 10, which is equal to 785.4 cubic centimeters. Now, let us move to the total surface area of a cylinder. So let us break this cylinder to see its individual shapes. So, we can see that we have two circles, one on top and the other on the bottom. Both have the area pi r squared. Then lastly, we have the curved surface of the cylinder, so we can cut it along the height and make it flat. We get a rectangle. The length will be equal to the circumference of the circle, which is 2 pi r, and the width will be equal to the height h. Therefore, the curved surface area is equal to 2 pi r times h. So, for the total surface r, we can add the area of all the three shapes, which is equal to 2 pi r squared plus 2 pi r, which can also be simplified to 2 pi r in brackets r plus h. Also, just take note that if they say the cylinder is open on top, it means you should not add the area of the circle on top, and if it's open both sides like a pipe, then you exclude all the circles and you will be left with the curved surface only. Now let us look at the volume of a cone. So, this line in the circle on the base is the radius r. This line from the base to the apex is our height h. And this is our slant height L. Take note that there is a right angle between the height and the radius. Hence we can use the Pythagoras theorem to find either slant height, radius, or height if we are given any of the two dimensions. So, for us to calculate the volume, we just need the radius r and the height h using the formula 1/3 pi r squared h. Let us do this example together. We are given a cone with radius 5 centimeters and height 7 centimeters. So, from our formula, volume is equal to 1/3 pi r squared h. If we substitute the values we get, 1/3 pi 5 squared times 7, which is equal to 183.3 cubic centimeters. Now, moving on the total surface area of the cone, again, let us break our cone into two-dimensional shapes. So if we do so, we get this sector of a circle from the curved surface of the cone, and the slant height of the cone will make the radius of the sector. So, the area of the curved surface is equal to pi rl, and remember that we can get L from the Pythagoras theorem if the value is not given. So, L squared will be equal to r squared plus h squared. Hence L will be equal to the square root of r squared plus h squared. So, now the second shape that we can get from the cone is the circle at the base. This circle has the radius r, and its area is pi r squared. Therefore, the total surface area is pi r squared plus pi rl, which can be simplified as pi r in brackets r plus l. Lastly, we will discuss about the sphere. For this one, there is no much explanation, so you just have to know the formulas as they are. So, the volume of a sphere is 4/3 pi r cubed, and the total surface area is simply the curved surface area, which is 4 pi r squared. So, as long as you are given the radius, then you can simply calculate. Thank you so much for watching. I hope this video was very useful to you, and once again, if you have any comment or question, just feel free to type it in the comment section. And don't forget to like, share, and subscribe. I wish you all the best.